All right, guys, Mr. Antonucci here. And in this video, I want to talk about transformations of quadratic functions. And what I'm going to do is I'm going to show you various transformations and how to determine, given a particular function, quadratic function, how to determine what the transformations are on there. And I will be using Desmos to figure this out. So the most general form of a quadratic equation is y equals a times the quantity x minus h squared plus k. So you don't have to know all that just yet to understand this, but if I start with a function f of x equals x squared, all right, we just have our basic parabola. And what I'm going to do is I'm going to run through a couple different examples of what happens when we change certain values. Let's start with this a. A represents a number that is multiplying the quadratic function. So if I put an a there and add a slider, so this is going to show what the graph looks like when a is 1. If a gets bigger and bigger and bigger, notice how the graph is getting narrower. This is actually stretching the graph vertically, because what it's doing is it's multiplying the value of x squared by a number greater than 1. Okay, now if I go from 0 to 1 and make my step size 0.01, you don't have to know all that, but all I'm doing is the value of a is 1. And I made it go so that the values of a are decimal values between 0 and 1. Okay, and now notice what happens is that the graph actually gets wider. So this would represent 0.3 x squared. That would represent 0.2 x squared. This will represent 0.1 x squared. So here's what happens. When the value of a is greater than 1, the graph is stretched vertically. And think about that. You're multiplying the graph of x squared by a number larger than 1, like by 2. So it's going to be twice as high. Okay. If the value of a is between 0 and 1, you're multiplying it by a fractional value less than 1, say a half. So when you multiply x squared by a half, it's only going to be half as high as it normally would have been at a particular x value. So that's going to, what we say, compress it vertically. Okay, now if the value of a is negative, all those same things are still true, but what happened to the graph when I made it negative? Right, it reflected it vertically over the x-axis. And so we would say that's a reflection over the x-axis there. Okay, so now let's talk about what the value of h does. So for the value of h, let me get this in here correctly. H is what I like to describe that as adding or subtracting a number inside the parentheses or inside the function. So let me just put g of x here as x squared. Okay, and that's what we would call our parent function. That's the original graph of the quadratic function. If I pick, say, x minus 1, what did it do? How did it change the graph? How about x minus 2, x minus 3, x minus 4? Right? Didn't it move it to the right that many units? Well, what happens if I add a number in there? So x plus 1, moved it to the left, x plus 2, x plus 3, x plus 4. Okay, so essentially the value of h is going to move it left or right, but opposite the direction you would think. So if it's x minus 2, you would think to the left since it's minus, but actually it's opposite the way you would think. So it would be 2 units to the right. Okay. Now this value of k outside of the function, that's how I like to refer to that. So we have x squared plus, let's say, 1. What did it do? Actually, what it did was it just shifted the graph up 1 unit. And if you think about this, you're taking the original graph of x squared and just adding 1 to everything that you squared. It's just going to shift everything up 1 unit. If I add 2, if I add 3, if I add 4, it just shifts it up that many units. If I subtract 1, guess what? Moves it down. Subtract 2, moves it down 2 units. Subtract 3, moves it down 3 units. And you can subtract like 3.45, okay? It's going to move it down 3.45 units, okay? So what have we learned? We've learned that there are transformations of vertical transformations up and down, and that's what the value of k handles, and it's just that many units up or that many units down. The value of h handles transformations to the left and to the right, and it's just opposite the way you would think. So subtracting a value moves it to the right that many units, adding a value moves it to the left that many units. The a value is going to stretch it or compress it vertically. And if a is negative, reflects it over the x-axis. Okay, so I want to look at a graph here or at a function. And what I'm going to do is type it in. And I want to see what we can come up with before we actually graph it. So 1/4 x minus 3 quantity squared plus 2. Now, what I like to do, and this is going to be helpful if you're asked to graph a quadratic function based on the way its equation is set up without a calculator or anything like that. What you do is think about plugging a number in for x. What's the first thing you would do? If I said plug 10 in for x, you would subtract 3. Well, that's the first transformation you'd want to list. What would that do? It would move it to the right 3 units. It would take the parent graph, the parent parabola, and move it to the right 3 units. Next thing you do is you would square that value, which that's why it's a quadratic function. And the next thing you would do is multiply by negative 1/4. The negative is going to flip the graph vertically over the x-axis, and the 1/4 is going to compress it vertically, okay? So we plug a value in for x. First thing we do is subtract the 3. That's going to move it 3 units to the right, square it, then multiply by 1/4. That's going to negative 1/4. That's going to flip it over, compress it vertically. And then the last thing you would do, if you plug in 10, is add the 2. And that's going to shift the graph up 2 units. So let me graph the parent function. G of x equals x squared. Whoa, all kinds of crazy stuff going on there. Okay, that's our parent function. Let me turn this on. Well, actually, let me do it like this. So first thing, if we have our square, our quadratic function like this. Okay, first thing, we subtracted the 3 and we said that's going to move it 3 units to the right. Boom, 3 units to the right. The next thing we said was the multiplying by the negative 1/4. Well, here's the negative, flips it over, and the 1/4 is going to compress it vertically. It's going to squish it down, okay? And then the last thing, we said the +2 is going to shift the whole graph up 2 units. Boom, there you go, shift it up 2 units, okay? So remember, the number inside the parentheses moves it left or right that many units, but opposite the way you would think. The number added outside of the parentheses or subtracted is going to move it up or down that many units. And the number multiplying the parentheses is going to stretch it vertically or compress it vertically, depending on if that number is bigger than 1 or between 0 and 1. And if the number's negative, flips the graph over vertically. Okay? All right, guys, hope that video was helpful to you in describing transformations of quadratic functions. If so, please do leave me a comment below and let me know if you have any math problems that you'd like me to maybe make a video about, and maybe I'll make it. Okay, make sure you subscribe to the channel and hit the bell for notifications for when new videos are uploaded so that you can be the first to know. All right, guys, Mr. Antonucci signing out. Take care.